Vitess is operating on a big black block. Captain Malcolm, Captain Falcon on a slick stack stock. Malcolm X meets Hal from 2001, texting X's on a street strap shock. And I digress, cause why by mess? You can test your fitness operating on Vitess. You'll that speed in French, steep third bench sense, rolling deeper than a bioluminescent creature in the Mariana Trench. Got nodes for days, MySQL is a prequel paid. How you gonna read the Lord of the Rings when you got the Hobbit before on the very first page? So to pull lines from Jaws, you're gonna need a bigger boat. It's a season to be sailing, not come in second thirds like Palin, when you certainly ain't the GOAT. Data on Kubernetes? Welcome to everyone who's here. This is our 22nd installment of the Data on Kubernetes community. My name is Bart, and it's an absolute pleasure to be here doing our last meetup of 2020. We will be back very, very strongly in 2021. And with that said, I was talking to Alkin earlier. In 2021, we're actually going to be expanding out to different countries and doing things in different languages. All right, so you'll be seeing this in the calendar and the meetups and social media. That we will be doing meetups in Spanish, we'll be doing meetups in Dutch, hopefully doing meetups also in French, German. We just need to get more people. Already talking to Alkin about getting something set up in Turkish. So we're hoping that the Data on Kubernetes community will get more exotic in 2021. We always want to, be as inclusive as possible. English is an international language, but it's also really, really fun to do things in local languages. So that's one update that we're going to be having. We'll also be having some resources towards the end of the year to send out explaining all the different things that we've accomplished since we started in July. It's been crazy 2020 for everybody, and for us it has too. But lots of new things that have been very excited about all the different folks that are coming into our community from tons and tons of different places and bringing their know-how and interest with us. So without further ado, today we are with Alkin, who has a very interesting background in many different senses. In a professional sense, he is currently working at Planet Scale, but if you check him out on YouTube, if you look for other talks that he's done, you'll see that he has been working with databases for over 20 years and has a lot of other professional elements that he will be sharing with us today, as well as some things he does in his free time. And we'll try to find some of the connections between the two. So Alkin, can you just give us a little bit of background information about yourself? How did you start working in tech? How did you get into this whole world?
All right, thank you very much. And this was a great intro. And I wanted to introduce myself also. I've been in this business, like you said, over 2 decades. But the way that I started was at my time and age was the computers, software, electronics was very interesting. It was evolving. I think I came in the right time where the revolution was made from the old microprocessors to the more advanced computers. And I did actually, out of interest, I did study on a vocational school on electronics. So I graduated in high school already coding. This is early 90s. So so that was like very early 90s. So that was very interesting to get into that. And then the way that you discover more, and then you find yourself whether you like more hardware, you're more software, and then you evolve. I ended up in the databases, and I never changed my point of interest. I've studied software development in the college, and then I did data management again in another degree. So never changed my focus at work, at academics, or my professional life all the way. So of course, coming from the early days, I had to go through the enterprises, and I was focused on few other enterprise database software and their different implementations. And then I met with open source, and I've met with MySQL. That was my a change of track within a track. So about 10 years ago, I've taken a role on an e-commerce company, and then I switched to MySQL over there, where I tried MySQL in prior occasions, but they weren't at scale. So the way that you go in more enterprise at scale with the open source, and the things change, and then you actually have to improve and continue doing that. So
okay, very good. We had a quick question from someone in the audience about your favorite kind of database, which I think you've responded, is MySQL. Do you have a least favorite database or one you're not such a big fan of?
So I'm actually, I don't actually necessarily have a least or most like databases approach. Even in the enterprise, I've done Informix, DB2, Oracle, Sybase. If I looked at them, I would actually compare and contrast between the pros and cons each, right? When I came to open source, I've discovered the things that open source world wanted to do that was already done in the enterprise world in much better fashion. But in some cases, the open source actually help people, fastly innovate. So that's the difference. And I don't actually have a favorite database, but what knowing and experience-wise, MySQL is my primary open source database. So, but for us, it doesn't take too long to switch database because the concepts are same, the fundamentals are same, database 101 is same. So based on that, you can switch. And the people who actually invented or improved these databases also come from the similar backgrounds.
I think that's interesting because it's something we talk about a lot too, whether it's vendor lock-in or hybrid cloud or wanting to avoid just being set on one thing, is that generally speaking, if you can do one, you can probably make the transition to the other, right?
Yes. And then if you're like an old school like me, along the way, the things that you think that it didn't work or not good, it excels and becomes $1 billion company along the way. And then you say, okay, there was something that they have innovated. And sometimes being bad is good because then it forces your developers or your community to do better, right? So so if we don't say like one is good or bad, there are pros and cons, strengths and weaknesses between the databases. And what happens along the way, you actually see they improve. Not only improve, they come up with a better solution between the databases. That's why there's not really a true favorite or not. But in my case, professionally, I'm more experienced and I feel more comfortable with MySQL than other open source databases like Postgres.
Okay. All right. I think it's a very, very fair answer and a good mindset to have in general when we're thinking about these things.
Right.
Now, can you explain a little bit about the work that you're doing at PlanetScale?
Yes. PlanetScale is actually a startup founded by the founders who actually worked on the Vitess project. So they actually come from a Vitess background, and as a commercial company backing up the Vitess project. Vitess is an open source project, and it's a CNCF graduated project. It comes from a Google roots, which I will get into that on my
okay, good, because I didn't want to get spoilers.
Intro. I don't want to get into that. I want to make the storyline right for that. My role at PlanetScale is I'm a senior technical manager. I don't manage any people right now. I'm part of the maintainers group. I'm official maintainer of Vitess, and I help the community, and which actually involves developer relations, and also I am in parts of the solution engineering and the customer success teams as well. So I do wear multiple hats at the point.
Okay. All right. Good. Well, if you want, we can jump right into your presentation. If that's
yes.
okay.
Let's take a look at a few highlights related for today's subject. I was kind of yeah. Okay. Can you see my screen?
Yes, I can perfectly.
Okay. So so we can actually go through that. I actually wanted to ask a sailing question before we get into that.
Good. I had some sailing questions, but I thought I'd save them for later.
So I've been thinking of what to ask. I think this is a good thing. What is the difference between a nautical mile and a regular mile, like the mile? So I don't know if we have anyone on the audience who wants to answer this question.
Okay, the thing is,
my trivia question.
As someone who comes from the imperial measurement system,
right? I am also imperial measurement system.
Yeah, the thing is, so
but
a mile
miles and the nautical miles actually not only used in the just in one area, it's also used in air and space also. Like so, it's not only for just for the sea, basically. And it's just like the answer is also funny for this. Well, there's also of course the scientific answer for that, but I don't want to get into that. I think this is like easily researched and found out. Maybe in school, I don't know, like my kids don't actually have the same school level of education that we used to have. In schools, we used to get, learn about latitudes and longitudes, parallels and meridians, right? So this is like degrees and minutes. So that's where it goes. Okay. But the short answer for this is Earth is not flat, because because circumference of the Earth, it's round and it's divided into degrees. You actually cannot tell a location with just or a distance or a speed with just like where it's at. You have to actually have the coordinates for the location. So between those 2 points, which we can say A and B, you actually have to measure it by the degrees of the latitudes and the longitudes. So that's the difference between a regular mile and a nautical mile. And there is actually a difference in distance. So it's one nautical mile is actually equal to 1.88 kilometers, which is 1,852 meters. This is a little strange because having lived in both imperial and metric systems in my life, I had to do this calculation at all times. And I always calculated with 1.6 because on the land nautical miles, it's 1.6 kilometers versus 1.8 on the sea. So there is a difference between the nautical mile and a mile, which is 1.15. So I think enough with this, but I think it's an interesting point. And then there's also a measurement of speed, which is also different. Has a completely different story about the knots. And when we are at the sea sailing, we tell our speed not on miles, not on nautical miles, but on knots, because there was a measurement system was based off of a knot, basically a knot that was actually left behind the boat and actually measured by calculating the speed of the number of knots that you actually pull together. So there's that story also. Anyway, I hope you find this entertaining information.
Very much so. I mean, Kubernetes, we're always talking about all these nautical things, whether it's about Helm or things like that. So it's
right. That's why that Helm chart actually fits right in to the slide. And I was like, okay, this is actually exactly what the sailing the Helm charts and the Kubernetes. Yes, that's about that. Okay, let's move on. So data on Kubernetes, right? So we have actually put our data in cloud, and that didn't solve our problem. And we also utilized some of the containers in the cloud and tried to automate that using whether it's Ansible or some other YAML files or yet another markup languages. But that didn't solve. So then we can talk about the techie things about Kubernetes. So and so when we look at it, I'm sure this platform has already discussed who needs data on Kubernetes, but the focus was on Kubernetes, was the containers and the stateless applications in general, right? So that's the regular team, and everybody knows in every level. So, but where does that come from? In my opinion, is it's coming from the microservices. So the application started from monolith to microservices, which we actually split up the applications into smaller footprints. And then we started putting them in the containers for a dev and test environments. And then we started deploying them on premises. And when the cloud actually evolved enough, we needed to deploy them on the cloud. And then what happened? We had actually a bunch of containers, just like on that picture, that is not actually orchestrated. And I don't think that was the only reason the Kubernetes came up. It's not only orchestrated, it was also inefficient. So if you stack them up all together, they didn't actually save enough CPU or hardware power that you actually needed to break it up in even smaller pieces, like the pods that we call today, wasn't possible. So the Kubernetes actually was born but this way. This is my take on it. Of course, other people may disagree, but then we go into the real question: who needs data on Kubernetes? Well, we actually put our application on Kubernetes. Why not put the data on Kubernetes? Because that was actually everybody started asking about. Okay, I'm actually moving in the cloud with my no data in the cloud, and what can I do with my data? So, well, there is a possibility that you can put your data on Kubernetes. One of which we're going to talk about today is MySQL, that you can put it on. Whether it's on Vitess or not Vitess, you could put it on for the things that you need to provide. So if we put our data, let's say our data store, MySQL in this case, in Kubernetes, we need to provide high availability, right? So that's one of the things. The other one is a persistent storage. My database needs a persistent storage that we cannot just like kill a pod and then just lose your data. That's not what the database is and it works. You should be able to provide backup recovery. You can't just fork out new pods and just think that it will work. Of course, you need to do traffic routing because that will be complex topology to manage, and if you need basically some sort of a proxy or a gateway or some in that nature, you need to be able to monitor this structure and also safeguard its data. So these are what is important in MySQL or any other data store in real life, and that you need to do that also in Kubernetes. And Vitess on Kubernetes is actually I don't want to say it's a perfect match, but it is actually proven match that actually Google started doing. So we go back in some time in history in 2015. Actually, Vitess predated the Kubernetes official initial release date that was deployed. So why this is important? Because the Vitess was an early adopter, while the Kubernetes being evolved in Google platform. So sometimes early adopters don't actually get everything they need because they're like the guinea pigs of it. But because they evolved together, they actually helped out each other to get better. I'm sure today's Kubernetes is not the same as 2015 Kubernetes, and obviously it's the same thing as today's Vitess is nowhere close to 2015 Vitess. It's much better and more complex implementation. So how do you run Vitess on Kubernetes? I want to actually talk about this. If you have questions, you can interrupt me, but please do so. This is not like a a long presentation. I just wanted to bring up the talking points over here. And so how do we run Vitess on Kubernetes? This is like a complex question. You could build your own because Vitess has enough components to run in Kubernetes. There is a way to do Helm charts. We as Vitess maintainers, I can probably speak on behalf of the team over here, don't recommend the Helm charts and deprecated them. There are multiple reasons for them to be deprecated, and the other option is the operator. Just one thing about the Helm charts. Helm charts were great initially to build something, structurally, and then step by step, it's clear. It's less organized, but then it becomes very difficult to maintain. So that's what my short answer for why just strike out the Helm charts. It is still doable, and I believe there are still people using it, and you can still use that and have them, but it's something that's hard to maintain versus an operator. Okay, hold on. Can you hear me?
Yeah, perfect.
Okay. All right. Hopefully this doesn't go into a sleep mode. So okay, so I don't know if you have any questions, but I can continue a little bit over here.
Yeah. Keep going. You're good.
All right, good. So so we said operator is one thing that's really interesting and good to use. But there are like what we are linking between the Vitess, MySQL, and the Kubernetes. So there are other options for MySQL. but they have actually different implementations for the same result, basically data on the Kubernetes, right? Basically, your data store is now on Kubernetes. So there's a Percona Kubernetes operator for XtraDB cluster. Percona also has as an operator for MongoDB, which is not part of this slide, but there is that. Press Labs has a nice Kubernetes operator for MySQL. Why I say it's nice, because it doesn't have the both pros and cons of having an XtraDB cluster or a Vitess cluster, and it uses the plain vanilla MySQL as a data store. Vitess has a Kubernetes operator, and there are others. Why I left it the others is there is one from Oracle. It's an alpha state. I don't know if there was any development over it. There's other initiatives from MariaDB as a data store. There are other operators, proprietary or licensed, and that perfectly works with MySQL. That's why I didn't want to get into the details of that, but I have researched these over the last few years, and I did not find anything that is we can compare. So okay, so what I want to come to the Vitess. So Vitess is a framework. We could call it a middleware between your data store and the application, and it has some massive important features like query serving, cluster management, and a thing called V replication. We call it a Vitess replication. So with all of that, it can do the sharded MySQL or unsharded. It can scale. Technically speaking, it can scale unlimited. You can scale as much as your cloud or your hardware scales. So there's no limit to scaling. It provides high availability, built-in high availability, and it actually has all these algorithms and the consensus algorithms built into the how it behaves. And it's also cloud native. You can take it from one cloud to the other cloud, or you could actually co-orchestrate between the other clouds. So that's more advanced implementation of Vitess. So all of that, you could do that in Kubernetes. What exactly is Vitess? Is basically Vitess is a MySQL driver. Basically, it has everything that the MySQL has. The ACID compliance. It provides MySQL 5.7 to 8x compatibility. It has its own control plane, built-in utilities, or open source utilities that are actually used commonly in the market. And it's also open source project that has multiple contributors, both from PlanetScale and outside of PlanetScale, and the users of Vitess are also contributors. So basically, it was a project that was released by Google to the open source community under Cloud Native Computing Foundation, and it's being open sourced. So it is a project that's run as an open source, and there's no intention to change that, and it's not possible to do that within the current licensing. So it's an open source project which is open to public. You could open issues, pull requests, and ask for help for that project. So that's where it's at. We look at that architecture. So basically, if we just take our MySQL piece out of it, it actually comes with the components that are actually suitable for Kubernetes environment also. This you can do that on a non-Kubernetes implementation, but the components of the Vitess architecture, basically you could just take out of the batch and put it on Kubernetes without thinking, right? So we said about query serving, we actually have the load balancer, and that actually drives traffic to the VT gate. VT gate is the query serving engine for the Vitess. And then it actually has a topo server if you have a sharded environment, that it knows where your data is, where your data is actually distributed. and the other components actually built into that control plane that actually drives all these utilities and internal resources that actually route your traffic from application server to the load balancer to the Vitess environment, and then from that on, it actually manages the data. And interestingly, you can do all of that inside the Kubernetes also, which lets you break it up into Vitess concepts that actually placed into the pods of those smaller containers. So,
and do you think, Alkin, someone was just asking, because from listening to a podcast from the founders of PlanetScale, having been, since the very beginning, they refer in the podcast to, Borg as a blueprint for Kubernetes. Having been inside from the very beginning, could we go so far as to say that Vitess is Kubernetes native?
Yes, we can say that. Yes, that's why it is designed. The design of the Vitess was, like I showed you, they actually came in the similar time frame, and design of the Vitess was in the mindset of Kubernetes. So I'm sure there was a lot of these, our founders, they also mentioned these. Okay, we thought about this, but because it wouldn't match the Kubernetes, mindset, we wouldn't be able to do that. So we had to find an alternate way to do things the way that it's actually in the future that'll fit.
And that's exactly it, because sometimes we find technologies where it seems that they're desperately trying to adapt to Kubernetes, but not necessarily doing things with that original mindset in place.
Right.
Perfect.
So, and this mindset helps you're breaking up into the concepts of Vitess, and Vitess has its own concepts. I don't want to get into the internals of it, but it uses tablets, key spaces, and stuff like that, which is also aligns with that, making the smaller pieces of, instead of saying an instance. In historically in databases, we would call an instance, it's just one big database that actually has one or multiple schemas in it, which also one or multiple schemas drills down to the tables and the columns and the data and the rows, right? So in Vitess, because the mindset of breaking it at smaller pieces specifically for sharding, you would have to actually have to come up with a different concepts of key spaces and the tablets and things like V indexes, Vitess indexes, and the sequence numbers, and so on and so forth. So hopefully this is not very complex. There are some key adopters. So this Vitess, it came from originally from YouTube to Google. It's been used in that mainly to solve scaling problems of YouTube about 10 years ago, but it's also started being adopted by others. There are many other companies, there are many other logos. I'm not sure I'm allowed to actually share some of them.
Of course, yeah.
But Slack is popular right now. Everyone uses Slack. We all use Slack, and Slack has a very good story behind why they needed to adopt to Vitess type of sharding system, and they also recently blogged about it, and you can read from Slack and Vitess story. There is Square, Pinterest. There are other very well known Silicon Valley companies that actually utilizes Vitess.
But would you say that the common denominator there is the question of scaling that was found in Slack?
It is actually, that's the common theme over there. You need to be able to reach to certain scaling, and there is no other option within your topology to scale other than that, and you actually go into this way of sharding. So but basically it's the sharding. It's the answer. And how do you shard in MySQL, which it doesn't actually have a native sharding methodology within? You actually have to have an option to do that, which is in this case is Vitess. And so basically, there are other adopters. You can look up, how it's been implemented. But the way that I actually think about when you say, I've adopted this topology, some of these companies are very large in the case. When we say Vitess in MySQL, it could be part of their scaling or scalable architecture data store. It doesn't necessarily mean it will be done. So MySQL, we also want to highlight that is for OLTP workloads. We're not doing, analytics. We're not doing machine learning. We're not doing other things that you could do with your data in Vitess architecture. What we're doing is what we would do normally in MySQL, you would still do, because the backend engine still officially a MySQL. It's running a MySQL. So we come with all that what the MySQL provides, but you also have to live with its limitations if there is any. And also we also come up with a framework that actually drives that technology to the front end, which is the application. So application needs to adopt that. When we say, okay, we adopted to that, it doesn't necessarily mean my entire application, the whole, areas of applications are working on Vitess. That's what I wanted to highlight. And I don't think that would be a true statement even if I said so, because I don't believe that could be possible. So we don't actually take everything and drop into the MySQL in real life. Why would you do that with the Vitess? So that is my general intro, and I'm open for questions. And I wanted to also highlight over here, we'll share the slide deck, but there's a Vitess Slack channel, and you can follow the Twitter channel also. If you have questions, the best place to ask questions is the Vitess Slack channel. It's open, and you can join, and then you can ask questions. There are maintainers, there are experienced engineers from the adopters, and super smart engineers are always around to answer probably already answered questions. So that's what people come into. Like when people research these things, because they hit certain speed bump or a wall, and that's where you actually search for it. And this is a good place to ask about Slack. And I'm also there.
And what would be some of the typical questions or maybe issues that people have? Let's say they've worked with another kind of operator and now they're moving over to Vitess. Are there any things in terms of onboarding or typical frequently asked questions that you seem to find?
The main theme over there is actually the sharding. So I actually prepared this because we have sharding stance over here, sharding widely and shard often. Because of the design of our data, it becomes very cluttered and big over a time, especially when you start scaling. You actually have to break it up in smaller pieces, and that's how it's manageable, and that's how all these companies actually solved their scaling problems. And that's, if you're actually scaling to a certain point, you need to, if you have the sharding in the mindset to come to that, that's where. And the questions actually in generally, from my knowledge, from my short knowledge, is on, one is how to migrate, basically how to take your existing data to Vitess, and two is prepare yourself how to shard, because then you're actually breaking up your data in smaller pieces by a logic, and that logic you have to actually adapt it to your application. What is the, it depends on a company. It could be clicks, like you're actually receiving. It could be geo distribution. It could be regions. From what I know, it could be a customer distribution. In Slack's case was the each workspace, like every workspace was different, and some of them were very large, some of them were very small, and then you actually create hot points if you actually put all the data in, and the others suffer. And this happened in our initial cloud migration also, which they called the busy neighbor. While your neighbor is busy consuming all the resources, there's nothing left for you, right? And this is the same thing in the data. If you don't actually split up properly, then you actually have a problem. This is on the Vitess side under reference. There's a nice read about sharding. I actually recommend reading this. Basically, this is how the Vitess mindset of sharding that actually has a basically in the replicas and then actually doing that. There are some advanced toppings in the Vitess that could be a little confusing for people who are not actually familiar with sharding. There is also resharding. You actually can put your data in and then redistribute later on. And that is more advanced thing to do. If or you actually put your data in and then split up, or you put sharded data into the correct shards and then start serving your data. And there are different techniques for that. One of which I mentioned is a V replication, is a very advanced replication. You can actually drive and replicate and do a cutover. So basically, these are the techniques that Vitess had already implemented and solved the problems of scalability issues in most cases. What are the drawbacks? I want to actually ask this question myself. Drawbacks are nothing is drop-in replacement, right? So there is some assembly required, and to get the right recipe out, right? So basically, you actually have to plan accordingly. You don't go out to, whether it's operator or not operator, or Helm charts, or you don't go out and just go to production with your data. You need to actually plan accordingly, and that's what my best recommendation is, to test out and basically run through your workflow, how you would do things in normal data store, and do that on Vitess, using Vitess, and then think about doing the Kubernetes approach also after that. And the Kubernetes is also evolving. It's Vitess is evolving, and things change. So backwards compatibility is a challenge at some points. And also I also always like to highlight one thing. One thing that is most important for your data is security. So security and compliance, make sure that your data is secure. So that's
it's funny that you mentioned that, Alkin, as well, is because when we talk about these things like security and other issues as well, is that it seems it's frequently something that's added much later in the story and not included in the beginning because it's boring. It's like feeling like you're doing police work or that you're restricting people's freedom. But how do you, as someone also who kind of works in developer relations, how do you sort of strike that balance between, fun freedom, but then also security and best practices with that?
So basically, there are some surrounding tools that we use, and each of those components, like in this case, it's a Kubernetes, right? Kubernetes, you need to actually follow the security procedures over there, and that's where it is, and your data store. Same thing with MySQL or any other data store. You need to actually follow their best practices first before you come into that point. But historically speaking, if you're going into this route, you already have some sort of a know-how in these best practices. So outside of, let's take the Kubernetes and Vitess outside of this conversation. If you were to ask me, what should I do as a best practice in MySQL, there is actually a list of things that you need to do, because that's the best practice for that data store. Mm-hmm. It would be similar, but slightly different in Postgres or MongoDB. You would actually have to go through those steps, make sure that your backend data store already compliant with that, and you carry that with you. Anything you add, you check those gaps, whether it's actually able to do that or it's compliant with that. There is a lot of moving parts into that, right? Your security certificates, your encryption keys, your encryption vault, your plugins to those vaults. There's a lot of moving parts depending on where you are. You need to make sure those each component are actually compliant first, and then they actually work together. So that is a little bit of a challenge, but it's doable. And that's why we say test first, deploy later. So it needs to be tested.
Yeah, of course. And some people say, no, when I'm in production, that's what I'm testing. But it's like, no.
Well, you test in production after you go live, but that's easier than basically migrating in production. So that would be a slightly different. So we're talking about migrating into a different technology or a different topology than testing in production. So there's always going to be test in production.
Yeah, some degree, no matter what.
At some degree, yes, there will be some degree of.
As someone who's been working with databases for quite a long time, you said getting started in the early 90s. What a wonderful time to be alive, the early 90s. But as someone who's been working with databases, you've seen all different kinds of evolution and different changes and things that have come into play. Do you think that this is the future of databases? We'll be moving entirely to Kubernetes, or is this, we have to look at this more as a case by case thing? What do you think is going to happen?
So I think from our storyline over here, microservices, containers, on-premises, and cloud, all these actually equate to Kubernetes, and for now at least. And Kubernetes and the operators are actually a good match for managing these things at scale. So I don't get pings. I used to get these a lot. I don't get pings a lot, but I just I got one ping today that I have just made a mistake in production. That shouldn't happen. That should never happen in 2020, right? So if you have Kubernetes, if you have the operators, the risk of making human mistake is going to be lowered. And at scale, making that at scale is not possible anyway. We cannot possibly manage, thousands of servers right now as a human, and that's why I agree with your statement that the future of data is going to be mostly on Kubernetes, as well as the future of non-data, like the application, is going to be on the Kubernetes right now. It's going to probably evolve in different directions, or some other technology will come. No technology lasted forever. So I can say that if within a 10-year or so, there'll be other technologies that will be better, faster, and secure than what maybe version 1 of Kubernetes, maybe called something else, and that can actually migrate some of the data stores and other technologies like operators embedded into it. So right now we have the luxury of writing our own operator, which actually helps the automation of things that you need to do manually, and actually you can program and give coordinates to things that you want to accomplish based on the logic that your application needs. So that's a good question.
All right. With that in mind as well, too, something we've seen, because we've talked a fair amount about operators, and maybe this is way too futuristic, but we're getting close to the end of 2020, a year which we're all happy to be ending. In terms of the future of operators, someone mentioned that there could be one operator to rule them all, in a sense, an operator that could learn all the different things that other operators are doing and sort of be able to be an amalgamation of all the different things that operators can do. Do you envision that as being a possibility?
I envisioned, when I looked at the operators first, I envisioned the operator could be more pluggable, and that you could write your own component into it, and that could be one thing. Or like an operator, like the Docker hub, like you have some market that you could actually download or buy and plug it into the main operator that actually does the thing that the operator is supposed to do. And then you can customize on top of it. Right now, the operator seems to me is like, okay, you do your own, and basically you're on your own also. And that requires talent and a skill level to be maintained for a longer period. Mm-hmm. Whereas and that actually makes migration and adoption difficult for smaller shops. Because today's startup, let's say you have an idea and you build a startup and you don't know whether it's going to pick up or not. Could be a $1 billion company in the next 5 years, right? We don't know it will go in a scale, and it does. I mean, we've seen so many startups that when they came to that point, well, they can actually hire and maintain that skill level, but along the way, they actually pay a price for those companies that I've seen, pay a price for scalability issues, right? They actually had to take major downtimes and outages and not able to invoice or accept customers, and we've even seen that during the pandemic this year alone. It was not too far from here, and like all the websites are down. We have lockdowns, and you couldn't order things, and they actually started having and this weekend, past weekend in Istanbul, in Turkey, we have a lockdown, mandated lockdown from Friday night till Monday morning. And before the game time, when the we have the soccer game, the football we call it, the online food options were limited, and we were getting not responding outages. So there's that. This is still happening. Because no one ever actually, millions of people in this country actually had to order a meal just 30 minutes before the game, right? So that is still happening, and that's where it goes. And I think the adoption to these technologies, if they were made more pluggable, that would make it easier to adopt.
Like you said, with the thing of being pluggable, as much as we can talk about just like the hard technical aspects, is a lot of this is user experience, developer experience. How is it when it comes to working with these things? And I think that's a lot of what our community is about, is to sort of get different feedback from different people and say, well, in this business case, this is how we applied this, and in this one we did it that way. But for a lot of people, is that there is a sort of necessity from talking to someone who works on the Strimsy operator. Jakub, he told me that you've got to know that there's going to be some DIY here. You're going to be trial and error. It's not going to work the first time. And that's eventually, though, is that I guess these are sort of the uncomfortable steps to getting to things that are more pluggable, so that it does become easier and people will be more likely to say, oh, you can do it this way. It's quite simple. This is how I did it. That being said, and talking about DIY, because we're getting towards the end, and we really got to hear more about sailing. So as someone with extensive, all right, so you have more salient experience and database experience, right? So, I mean, we're talking about a solid amount of knowledge, of experiences of being in different situations. How do you relate what you do when you're at sea in terms of stuff that you're doing to also your professional life, also considering that you do work from your boat as well too? I'm just saying, in terms of the mindset that's necessary to be a good sailor, how can you apply some of those learnings to the things that you're working on in Planet Scale, working with the Vitess Operator, or anything about running databases on Kubernetes?
So the database is itself the data store, and it's super critical, and it's super critical for the business, your sponsors, your customers, and especially for the security of the data. And I can relate that to being on the sea. Is the similar thinking, is you need to have a practical thinking, and you need to solve things fast and with as little damage as possible. And in a situation where things go south at the sea or in the database in front of a console, you actually have a down database. You need to bring that up, and it's not coming up. Is not different than your engine not starting while you're drifting to the rocks. So you need to be able to improvise over there and then find a solution as quickly as possible that will make you not actually lose your data or your life or your boat. So these are actually correlated.
Yeah.
And I don't actually think about it. It's actually you grow into it, and then hopefully you have enough skills, background, and knowledge to find a solution as fast as possible. I'm lucky that I did not lose a major data in my professional life, but I've been a witness to losing a data. I've been witness to having a very long downtimes. I have done 20 something hours or 32 hours non-stop, non-sleep recovery situations. I've been in the data centers that's cold enough, like an Arctic North Pole, and many situations. I have not been in the situations like in the sea, because that's more predictable. than your database situations. So we proactively look for the weather forecast. We plan our routes. We play on the safe side. We don't go and adventure things that if we don't have to, but you could be caught into unpredicted weather situations, and that's why we have actually a thing called in databases, a thing called a proactive monitoring, proactive actions, proactive things that you could do to avoid disasters that can happen.
And with that in mind as well, like you said, is that there is a certain plan, and then there are other factors that are going to get involved. I think that's a lot of it, is that, don't be alarmed if things don't work exactly the way as you plan. But since you touched on a couple of war stories there, with what happened, yesterday with Google being down and this issues of, storage capacity and things like that. What do you think that says about something as big as Google? Sometimes you might have the image of, it's too big to fail. It's impossible that something can go wrong. What do you think that says?
So it's the bigger that you have, arsenal of data store in this case is a data service. It's a bigger problem. You have an army of engineers to design and to perfect, but there's always going to be something like that, and the scale of downtime is going to be big. And that's actually happening on others that we don't hear because they're not as big as Google, and their services are not as used as much as the other services, but they also do go down. And AWS had an outage recently, just a few weeks back, and Facebook had an outage. So these all giant, large, companies will have some sort of an outages. They tried they take actions to prevent them. I have not actually read the postmortem. I don't think it has come yet. There'll be some publishings on the Google side. I've read the AWS one, had impacted a funny story and a lot of IoT devices, and the question was asked, what was impacted by my Roomba didn't work, or my like the cat feeder didn't work. Those were like a few interesting answers that I got from my friends, and and this can happen to anyone. So there's going to be some outages. There's going to be issues with services. So I'm not saying it's impossible to prevent, but there's going to be some issues.
I think that's the problem, is that some people just got this certain image that these things, once again, it's impossible that they can possibly fail. But at the end of the day, everything breaks once in a while, and that's it. I think also maybe because of 2020 being such an odd year with many changes, that is like, this is the last thing that could possibly happen, is that we're in December.
Yeah, it has been an interesting year in that sense. Yes, I agree, but we're not over yet. So
yeah, and speaking of which, we've got a little bit of time left, and we got one more question from someone in the audience.
Okay.
To which extent are Oracle's pluggable databases similar to Kubernetes-based instances?
So in the Oracle side, Oracle actually had implemented consistent data stores and cluster management, and long enough they have an experience in doing that with the enterprise, because I have an enterprise background. I know how the rack worked and the design of it. But in the Kubernetes, you actually have to have a similar technology, which in the open source world, Oracle has a group replication, which actually allows you to, similar to Galera Percona XtraDB implementation, with a algorithm that actually allows you to have primary and a replica servers that you can fail over within the Kubernetes environment. They are going to evolve into those, but the drawback over there is those instances might be large, and there are some not a showstopper, but there are some challenges in larger data store. I can give one small example. If you have a terabytes of data, and those terabytes actually split into a cluster with a primary and replicas. If you can imagine a scenario where you actually distributed your reads and writes into those, if your primary server goes down for some reason, you're failing over to a replica might be long enough. And if there are not enough replicas available, you may actually have to clone, and that may take a long time to do that. So there is really not a good solution for that yet, unless you break up your data into smaller pieces by sharding.
Aha,
So
and then we come back and we come full circle.
so I'm gonna always come back to that. And actually, there is that, even though disk speeds with the SSDs improved, we have advanced pipelines of high IOPS networks. You still have a writing speed of certain limitations. It's not unlimited, and not everything is in the memory. So it's in the persistent storage, and that because of that, you still need to read and write. And all these things don't happen on the fly. It has to read and write. There are some techniques that was implemented for snapshotting and stuff like that, but the logical volumes are not always good for consistent storage, unless you actually have implemented certain techniques to avoid data loss. So I don't want to get into those details, but if there's anybody who wants to actually ask questions into those areas, why we are thinking that way, what we have seen this story, and I have had a lot of experience with the customers that actually gone through this and didn't work for it. So all those technologies that you actually have, pluggable databases, cluster management systems, you actually still have some sort of a drawback or a catch-22 situation where you may have to break it up into smaller pieces, because then your maintenance becomes a difficult, right?
Yeah, very, very good. Perfect. Well, we're pretty much just on time to finish, right in an hour. But before we do, we mentioned early when we were starting out, our friend who's with us, Angel, was going to be busy while we were talking. And what Angel was doing was creating this wonderful drawing that, Gorka, can you share Angel's drawing? Alkin, can you stop sharing your screen maybe?
Yes.
Okay. So we can share ours really quickly. I think, can you see my screen?
Yes.
Very, very good. So as we were talking, Angel was very patiently absorbing all the things you were talking about and trying to create an artistic vision of all the things that were mentioned. And particularly as you are a nautical man, it was only fitting to get you on a boat. And anyway, thank you so much for your time, Alkin. It was
Thank you very much for inviting me.
We definitely gotta, we'll be sharing the slides for folks so they can take a look later. Also to make sure to get on, and if you have questions about Vitess, get in their Slack, ask questions. Like you said, they've probably heard it before. They've probably responded to these doubts before. Once again, strong community feeling, people that are willing to help out. This is a great way to finish our meetups for 2020, because it was a way to sort of incorporate a lot of the different things that we've been discussing along the way. I feel like we have more confidence in how we approach some of these things because of the other examples we have from other speakers. But your ability to tie all these things together, and particularly with so much experience and wisdom working with databases, we're very, very lucky to have you as a speaker. So we will hopefully be seeing you as a speaker at either at a meetup in English or in Turkish or on a boat or on land or somewhere. Always happy to. But we will definitely be seeing you again, Alkin. So thank you so much for your time.
Thank you very much for inviting me. Thank you.
Our pleasure. Take care. Bye-bye.
Bye now.